Hi, everybody, and welcome to this quick introduction on the unit on the day. There are basically different ways of approaching this issue. How do we define it? We can define it as basically based on the clock, which is 24 hours is a day. But in astronomy, or at least the way that is properly defined in astronomy, is based on the rotation of the Earth around its own axis by taking the sun as a reference point. Well, there are different ways of approaching this issue. One way is to look at when the sun rises or sets and wait for the next time when it rises or sets. But that presents a difficulty in the sense that that depends on the seasons. As you know, because of the tilt of the axis of the Earth, the sun changes positions of where it rises and where it sets, and also it changes locations too, depending on the summer and the winter. So that's really not a good way of doing it. The best way of doing it is actually using from noon to noon. From noon to noon, what I mean by that is, if I am looking due north, obviously behind me is due south, and take a line in the sky, hypothetical line, that joins the due north all the way to the due south, going by my zenith, going by the point immediately above me. That is my meridian. As long as the sun passes by that line, it doesn't matter where. Obviously, in the summer, it's going to be closer to my zenith, and in the winter is actually away from my zenith toward the horizon. For the northern hemisphere, of course, then in this case, I will call it noon. I will wait the next time when that happens, and that is a day, 24 hours. Okay, so this is how we define the day. So let me share with you the screen to see how that works. Where's the share button? Okay, here it is. So I'm here. This is my position. I'm looking due north. Behind me, of course, is going to be due south. Okay, the line that joins these two in the sky, passing by my zenith. So above my head is the zenith. Okay, this line is the meridian. So wherever the sun crosses today, it doesn't matter where, depending, of course, on my latitude and the season, the time of when we're doing this observation. It could be lower in the summer and higher in the winter. Then in this case, what I meant by lower, it's going to be higher in the sky, of course, okay? And this line is going to be lower, closer to the place where I am standing. Then in this case, this is the first noon. The next time this happens is going to be a day. So the next noon, is going to be a day. So this is how we're defining a day here. However, there is a challenge in here, and let me explain what that is. So we're looking at the sun in here. So this is the position of the sky, sun from day to day. Obviously, there is a challenge. Let me explain why that is. So here is the sun. And in here is the Earth. I'm going to draw it a little smaller, albeit it's not to scale, okay? And I'm looking at the sun. This is the first noon, when it passed through my meridian. The Earth is going in orbit around the sun, and behind the sun, everywhere actually, are stars. So I'm going to look to far away stars in here. So a little later, the Earth will spin. So I was looking in here earlier. Now I'm looking in here because of the fact that the Earth is spinning. If I wait until the Earth completes a full cycle, that means I'm going to look at the same direction as I was looking to begin with, toward the background stars. So the Earth has completed a full cycle, okay? If you wish, a day, if I'm not looking at the sun, if I'm looking at the background stars, this is called a sidereal day. Obviously, I still did not see noon. I'll have to wait for the Earth to spin a little more than that to be able to see the sun again. So this is what I defined as being the day. Now it's noon again. So it was noon today, and the day later, this is the other noon, and now we have a full day. So this is a solar day with respect to the sun, and this is with respect to the stars. So the sidereal day is with respect to the actual rotation of the Earth. So the Earth spins a little faster, if you wish, than the actual solar day. So this is 24 hours by definition. So this must be less than 24 hours. As a matter of fact, it's 23 hours, 56 minutes, and 4.09, I think, seconds, which means 4 seconds and 9/10 of a second, okay? Probably with a little bit more accuracy, you're gonna pick up more digits. So this is the actual sidereal day. This is the actual rotation of the Earth. But because we agreed from noon to being 24 hours, this ended up being, and it's always going to be less than the solar day. That means the actual rotation is slightly less than the full day. Well, I mean, I can talk a little bit about the other one, about the issue, and I hope that you guys will read the unit. This is from Unit 7, by the way. This is part of your assignment anyway. You're supposed to do the reading. About the effects of the rotation of the, of the tilt of the Earth and how far, especially if we're going to use the sunrise. If you go above a certain degrees in your latitude, namely because of the fact that the Earth is tilted 23.5 degrees. So if you move at 90 minus 23.5, which would put you at exactly 66.5 degrees in latitude, if you move to that point, there are times in the year where the sun never basically sets, stays above the horizon, and at least during the summer solstice. And the opposite is true during the winter solstice, where it's going to not appear at all. So because of that, then where is the sunset, where is the sunrise? So there is a problem. So we cannot define it, as I said in the beginning, based on sunset or sunrise because of this problem. Okay, so it's going to be an issue in there. So it's not, they're not going to have days or what, or they're going to have no nights. So this is a better definition, and it's a good one that works. Okay, any time that is before the prime meridian is called an anti-meridian. So this is the morning, basically. We call it AM. Anytime after during daytime, of course, after the meridian, after when noon happens, we call it what is it? Post meridian. Anyway, it's referring to its position with respect to the meridian. So this is where the AM and PM originate from. Obviously, there is a problem now. How are we going to define it on the entire planet? What we did on the planet is, I took the entire planet and I opened it into some sort of a rectangle, is that we agreed that there is a prime meridian. That is what we call the 0 hour, okay? When the sun is at noon on that place. This is the one that passes through England, through Greenwich, to be more specific, and this is by convention the prime meridian. Now, if I go 180 degrees, because the Earth is actually has a spherical shape, so it's actually the whole thing is circle. So if I go 180 degrees on the opposite of it, that is where the date line, the international date line, international dateline is. So in there, basically, there is a difference between this is tomorrow and this is today. Or if you wish, this is today and this is yesterday. Okay, so this is what defined basically the day limits. So this is a transition between the two, as opposed to this one being where the 0 hour is. Okay, so again, what I said in here, 0 hour, it's actually noon, 12 p.m. is when the sun is actually immediately above your in the meridian. Okay, so this is how we define it. So this is the starting. So when it's the middle of the night, so it's going to be 0 hours, and everything shifts one way or the other depending on how you are. Okay, so these places that will be already in the tomorrow. If this is 12 p.m., this is will be 0 hours a.m. and so on and so forth. Okay, so this is how the time, and because we're using 24 hours, we're dividing the entire circle into 24 sections. So you have 360 degrees, that's the circle. You divide it into 24 hours. That's how it agreed to define the clock is. So this will give me 15 degrees per hour. So every time I travel 15 degrees on Earth, an hour changes. So a new time zone is added or subtracted, depending on which direction I am going. Obviously, if I'm going toward the east, I have to add an hour. Okay, if I'm going to the west, I have to subtract an hour. So that's, I have to adjust my watch. Okay, every 15 degrees. So every 15 degrees, how many is that? We know that 360 degrees corresponds to the circle of the Earth, which is about 40,000 kilometers. And 15 degrees, which is 1/24 of this distance, roughly is what? I'm trying to see how much is that on a calculator quickly. So what I'm saying in here is, what is it? 40,000 divided by 24, about 167 kilometers, or 100 miles, okay? About 167 kilometers, or roughly 100 miles. Every time I travel about 100 miles, is it? No, it should be more than that. Here's a problem with this calculation in here. Okay, I'm making a lot of rough estimates in here, including this number. And the other thing also is that actually the time zones are not defined as such. They're defined using politics, and depending on how you want to group things, and they're using the geography of the region where to determine the different time zones. So if you look at the dateline, for example, I drew it as a straight line, but it's not really a straight line. It's really a zigzaggy pattern depending on the different islands they want to be on the same region. This is in the Pacific mainly. And the same thing with the prime meridian. Most of Europe actually is not in the Greenwich time. It's actually shifted 1 hour to the east compared to England, with the exception of Portugal. So that's really, although Spain, if you look at the map, it's actually toward the west, but it's still part of the European time zone, which is slightly different. The same thing actually with Africa, same thing with all of the different countries. So there is a politics involved in here, and there are actually geography also involved in here into determining the time zones. But these are basically how the time zone are more or less are defined. Part of the issues with the time zones is a daylight saving time. Daylight savings time. Because of the fact, as you know, from the tilt of the axis of the Earth, there are times when the actual daytime is longer than the nighttime, and vice versa, when the other one reverses in the winter. Then some places in the world, most of the places in the world, they basically adopted this this convention where they change the sunrise and of course sunset at the same time. They shift the entire clock, basically, sunset, later to have more daytime, because more day, you have more light during that time. So that's basically a part of the convention, that is to have more hours during daytime. That's basically not exactly more daytime, to have more hours during daytime. Okay, so that's really how the purpose of the daytime daylight savings time. So anyway, this is basically in a nutshell how the day is defined. These are some of the concepts that I want you guys to remember, and you are required still to do the reading for unit 7. Thanks. Thank you guys.